Greetings and welcome. This is Dr. BDY Sunil, Associate Professor, Mechanical Engineering Department, Institute of Aeronautical Engineering, Hyderabad. In today's session, we will be seeing the definitions and terminologies in particle dynamics and energy principle, which is the fourth module of your engineering mechanics syllabus in UG20 regulations. So let us start the definitions. The first definition, what we are going to learn is what is motion. So this part of engineering mechanics comes under the dynamics criteria, wherein we are going to study the characteristics of the force that is involved in the system when the object is moving. So till now, whatever you have seen the previous syllabus, it is regarding the objects which are in stationary mode. From now on, we are going to see the objects which are moving. So the objects will not be at rest, the objects will be moving, and we are going to see the characteristics of the force that is involved when the object is moving. So first definition which we are going to see is what is motion. So the definition says the continuous change in position of a body with respect to time and relative to the reference point or observer is called motion. So here the three important terms which we can discuss are given like this. It is the continuous change and the position and the reference point. So it may be, the reference may be a point or another object or an observer, whatever it may be. So these are the three important terms that we can understand to clearly see what a motion is. So a body is said to be in motion when it is changing its position. The position is with respect to some reference data. So when body is continuously changing its position with respect to some reference position or reference datum, then it is treated in motion. It is treated in motion. So once it is changing its position continuously with respect to some reference, it is treated as moving, or we can say that the object is in motion. Coming to next one, what does position in dynamics mean? So position, as we have discussed previously, any position of an object will be considered with respect to some datum or some reference point or reference line. The datum or reference may be a zero-dimensional object, one-dimensional object, or two-dimensional object, or three-dimensional object. So what we are considering for the reference is not a main thing to be considered for the object's dimension, but the criteria which we need to consider is the datum, wherein the position of the object with respect to some reference remaining the same. So the position means the location of a particle with respect to origin or reference. So till now we have seen that position of the objects with respect to some datum. In your previous sessions or previous classes in mathematics or physics or chemistry, in those subjects you can see that the origin is the point which you will be considering for each and every point that you are going to place. So that would be one reference. So for a wall and a person or a human being, the wall forms as the reference or datum, and the position of that person will be taken with respect to the distance from that wall. So the same person standing at a steady state or standing at some position will be having two different distances with respect to two different references. So with respect to a wall which is nearer to the person and with respect to a wall which is farther from the person, the distance changes. The position of the person doesn't change, but the distance reference point is changing. So the reference datum is considered, which is being considered, changes. So when a wall which is positioned from that human being or person standing maybe 2 meters apart, and another wall which is at 8 meters apart from the position of the person, the distance is changing, but the position of the person is same. That we are going to consider. So the position in dynamics mean that the location of a particle with respect to origin or reference. Next one is the define kinetics. So we have already discussed that the dynamics of engineering mechanics, which is being classified into statics and dynamics. In the dynamics part, we have seen the rigid body dynamics as well as the position of the objects. So in dynamics, we can say kinematics and kinetics. So these two classifications are being considered, wherein kinematics is the term or the branch of that engineering mechanics where the movement of the objects are being considered without considering the source of that movement. That means we will be only considering the change in position of the objects without considering the forces that causes that change in position. For example, a ball, a football, which is being kicked up by using our leg power or leg strength, then the ball moves. So the movement of that football, if alone is considered without considering the strength which is being used through this leg to move that ball, then it will be treated as the kinetics part of the dynamics. Kinematics part of the dynamics. Wherein if the strength that is being used, the force that is used for kicking that ball is also considered, then it will be treated as the kinetics of the dynamics part. So that is the difference between the kinematics and the kinetics. So dynamics will be treated in two ways. One is kinematics and another is kinetics, wherein the kinematics part, we are not going to consider the forces that are involved in the movement of the object, wherein the kinetics, we are going to consider the forces also. So along with the movement of the object, we are also going to consider the forces that are involved in the system. So now let us see the definition of the kinetics. So the kinetics is the branch of classical mechanics that is concerned with the relationship between motion and its causes, specifically forces and torques. So the cause of motion is also considered in the kinetics part of the dynamics. So this is the definition of the kinetics. Now coming to next one, which is explain the term rectilinear motion. So this is the definition given. If the path followed by a particle is a straight line, then such motion is called rectilinear motion. Right? So the continuous change of the position of the object with respect to some reference or with respect to some datum is a straight line. That means the object is moving in a straight manner without any deviation of the position and here and there. It is continuously moving in the straight line. Then such motion is called as the rectilinear motion. Coming to define curvilinear motion. So the definition says, if the path followed by a particle is a curve, then such motion is called a curvilinear motion. So here you can understand that the change in position of the object, the continuous change in the position of the object is termed as motion. The object is in motion, and then this change in motion is not in a linear fashion. That means it is not moving in a straight path and it is taking some curves. It is moving in random fashion without traveling in a straight manner. Then such motion is treated as the curvilinear motion. So the object will not move in a straight path, but it will be taking some curves. So this is treated as the curvilinear motion. Object is changing its position. Continuously the object is changing its position, but it is not in the form of straight line. So it is treated as the curvilinear motion. Now next one is define the term plane motion. So plane motion is nothing but the change in position of the object, continuous change in position of the object in a two-dimensional path or two-dimensional plane. So that can happen in a single manner, that is having two linear as well as the curvilinear combination of the movement. So the object will take the change in position as rectilinear motion and curvilinear motion. Both combination of the movements will happen. So the definition says plane motion is combination of both translation and rotation. So for understanding this plane motion or the combination of both translational motion and the rotational motion, we can consider the arm, that is link, that is being connecting the two wheels of a train wagon, right? So when the train is traveling on a track, so what happens? This link that is connecting the two wheels, it will continuously moving in the circular position. It is continuously moving in the circular position. So it will be taking linear fashion movement as well as the circular fashion. So this is an example for the plane motion which we can consider. So the term plane motion is defined as the combination of both translation and rotation. Coming to next one, which is what is inertia? So inertia is the term which is used in our Newton's first law. So the object continues to travel in its position, or we can say that it will continue to be in its position, whether it may be at rest or when it may be in motion, it will continue to do it unless and until some external force is being acted. So in this way, we can consider the position of the object and the movement of the object both. And when the force is being involved in the change in position of the object, or when the object is staying at rest, then we can say that the inertia is being implemented. So here the inertia term is defined as property possessed by a body by which it resists the change of state. That means when the object is in a rest position, or when we say that an object is at rest, it will continue to be in that position itself. It won't change its position until and unless the external force is being acted upon. For example, we are placing a water glass on the table. Until and unless someone comes and picks up the water glass, it won't move. That means we are acting, we are applying some external force onto that glass which makes the object or the glass to move. So if no force is being acted upon that glass, then it will continue to stay in that position itself. Even though some water is poured in it and the glass is being placed on the table, it will continue to be at rest. It will continue to stay there itself unless and until some third person or another person or some force is being acted upon that glass and someone picks up the glass. So that is the state it will continue to be in. Then once the glass is picked up, it will continue to move until it reaches the mouth of the person, right? So that means we are applying the force and we are making the glass to move, and until and unless we stop the movement of the glass, that means again some external force is being acted upon on that glass, it will continue to move. Again, it will resist the change in position. So we can say that the body which resists the change of its state, whether it may be rest or in motion, it is treated as the inertia of that particular object. So the property possessed by the body by which it resists the change of state is treated as the inertia. Coming to next one, what is momentum? So this momentum term is involved in both velocity as well as the mass of the object. So we can say the quantity of motion possessed by a body, it is the momentum. It is measured by the product of mass and velocity. So it is the matter that is being contained by the object and the velocity with which the object is moving. Let us say the matter that is being contained is m. So m mass of the matter is being contained by this body, and that body is having a velocity of v. Then we can say that the momentum of this object is treated as the product of mass in velocity. Product of mass and velocity. So this is defined as the momentum. So whatever matter that is being contained by this object, the quantity of that matter and the velocity with which it is moving. So both combined, the product is given as the momentum. Product is given as the momentum, and that is treated as the m into v, where m is the mass that is being contained or possessed by that object, and the v is the velocity. So the quantity of motion that is possessed by the body is treated as the momentum, and it is measured by the product of mass and velocity. Coming to next one, what is DLM Number's principle? So this is very popular principle that is being used in the calculations of the kinetics problems, wherein the force that are being involved in the system when the object is in movement will be considered, and the inertia term is going to be introduced into the system. Whenever some force is being applied in a system and the object moves, then the inertia will be acting in the system, wherein the change of state of that object is being incorporated because of the force that is involved in the system. So to understand the DLM Number's principle, we need to understand the inertia, which is been already discussed. So inertia is nothing but the resistance of the object to change its state. So with this we can understand that always the inertia, property of inertia by that object or in that object will be in the negative form. That means in whatever direction the object is moving, or we can say the acceleration of that object in one particular direction will represent the direction of the inertia. So for example, if we understand this object is having the inertia in this acceleration in this direction, that means the object is moving in this direction with some acceleration a. That means the object's movement is being implemented because of the application of the force in this direction, and the object is accelerating in the direction shown here. So obviously, prior to this application of force, the inertia of this object will be acting in the opposite direction of the movement or the acceleration. So that we are going to consider. So that inertia force is also considered in the form of mass into acceleration. The term force is being represented as mass into acceleration. F is equal to ma, and this is the direction in which the inertia force acts. In the other form, we can consider that the minus of the mass and acceleration product, the negative form of the mass and acceleration product, is considered as the inertia force. So this negative term is the representation of the direction of the inertia force. So that we need to understand. So this is about the inertia force and implementation of this inertia force in the problems that are involved in kinetics. So the definition says, DLM Number Principle states that system of forces acting on a body in motion is a dynamic equilibrium with the inertia force of the body. So nothing but the object will be in equilibrium state. Even though the object is moving, the object will be in equilibrium state, and that equilibrium state will be in a dynamic form. That is, the object is, because of the movement of the object, we can say that the dynamic equilibrium of the object is achieved with the inertia force. So when the object is moving, because of the application of the forces, when the object is moving, because of that inertia force, the object is in dynamic equilibrium condition. So that is the reason when you consider some way the vehicles or bus, let us take an example of a bus. Even though the bus is taking some turn, whether it may be right side turn or left side turn, when the driver steers the bus and the bus takes the right side turn or left side turn, the some movement will be taken in the bus. We can observe that, right? When the bus is taking right side turn, we can feel that the bus is trying to tilt in the left side direction. That means the inertia force is happening there. The inertia force of the bus, the inertia of the bus is making the bus to continue to move in straight direction. But when the driver steers the bus to the right, the bus will make a tilt. Even though the bus is being applied in the opposite direction forces, it will not roll over because of this inertia forces. And the dynamics of this bus construction is made such that even though number of forces are being acted upon onto the bus, when the bus is taking turns or moving up a hill or going down the hill, the stability of the bus doesn't change. The stability of the bus will be maintained. So the dynamic equilibrium of this movement, the object of that is bus, is maintained or happen because of the inertia force of that body. So whenever we consider the dynamic equilibrium of the object, it will be happening because of the inertia force of the body. So that is the statement of the DLM given. So DLM principle states that system of forces acting on a body in motion is in dynamic equilibrium with the inertia force of the body. Now, the representation of DLM principle. Give the representation of the DLM principle. The representation is given in the form of R minus MA is equal to 0. You can observe here, wherein R is the resultant of all forces acting on a body. So R is the force. And the term minus MA may be looked as force of magnitude, mass into acceleration, applied in the opposite direction of the motion, and is termed as the inertia force or reverse effective force. So in the previous question, the DLM principle, we have already discussed this. the inertia force, that is treated as the mass into acceleration taken in negative form. This negative symbol represents the direction in which the inertia force is being acted. So for understanding this, you can see here the force term is given as the mass into acceleration, that we all know. If at all this mass into acceleration is taken to the left hand side, then we can get it as F minus ma is equal to 0. Here the term F is nothing but the force, and this force is taken in the form of the inertia force, in the form of the force that is being taken by the resultant of all the forces acting in the body. So if there are number of forces acting, we are going to take the resultant of that force. The movement of the object, always remember, the movement of the object is taken in the direction wherein the resultant of all the forces is acting. So obviously, even though some number of forces are acting in different directions, as shown here, ultimate movement or direction of this object will be happening in the direction of the resultant force that is being acted upon. So here we are going to take, in the place of force, we are taking the resultant of the forces, and the term minus ma is taken as the inertia force representation. So this 0 here represents that the system is in equilibrium. Understood? So the system is in equilibrium because of this inertia force. So whatever force, that means whatever force that is being acted, so resultant is equal to 0. Resultant is equal to 0 is the statement for the system in equilibrium. Now, how this resultant is becoming 0? The resultant is becoming 0 when the inertia force is being given in the system. So this inertia force is given in the negative form, and this negative form represents the direction of the inertia force. So ultimately you can understand that the dynamic equilibrium of the system is happening because of the inertia force. So that is the representation of the DLM principle. To understand this, you can solve couple of problems, number of problems in the kinetics, wherein we are going to implement the inertia force in the system, and we are going to identify the unknown values. So here you can see the representation of the DLM principle is given as R minus ma is equal to 0, where R is the resultant of all forces acting on the body, and the term minus ma may be looked as force of magnitude mass into acceleration, that is m into a, applied in the opposite direction of motion, and is termed as the inertia force or reverse effective force. So this is the representation of the DLM principle. Now coming to next one, define the term angular velocity. So this angular term, whenever you are going to see, the angular term represents that the object is having a curvilinear motion. When the object is experiencing a curvilinear motion, then the term angular velocity, angular acceleration, angular displacement will be coming into picture. So the term angular velocity is defined like this. It is defined as the change of angular position with respect to time, or simply rate of change of angular position. Here again, the position is nothing but the state or the object's position, the object's state with respect to some reference. So that we need to understand. So the term angular velocity is defined as the rate of change of angular position. So dynamically, if the position is changing, continuously if the position is changing, that scenario or that working of the object or the movement of the object is considered as the dynamics part of the mechanics. Coming to next one, define work done by a force. So we all know the formula for the work done, which is the force into distance traveled. That is, work done is equal to F into S. But the technical usage of the work done equation is very, very important in engineering mechanics, wherein the direction of the object's movement should be considered compulsorily. So now we have understand that work done is given as force into displacement. Here, the term work done is being involved with the force that is being acting in the system and the distance to which the object is moving. So for this to happen, what we need to understand is work done that is given in the form of force and displacement or distance traveled is also a vector quantity. That means we will be considering the direction in which the object is moving. So ultimately, the movement of the object will be happening because of the force that is being involved in the system. So whatever direction the force is moving or the force is being applied, the same direction the object will displace or the object will. Hence, ultimately, we can understand that the force which is being applied in the system defines the direction of the movement of the object. So ultimately what we can see that the object which is moved in particular direction of the force will be considered as the work done by that force. So the definition says work done by a force may be defined as product of component of force in the direction of motion and the distance moved by the body. So the component force is nothing but the force that is being involving or making the object to move in that particular direction. So in whatever direction the object is moving, the forces that are acting in that direction only are making that object to move, or the work done by those forces is making the object to move. Hence, we are going to consider the work done by a force may be defined as product of component of force in the direction of motion and the distance moved by the body. Next, what is the unit of work done? So the unit of work is Newton meter, which is called as the joule. So Newton meter is called as the joule. So wherein the Newton is the unit for force and meter is the unit for the distance to which the object is moving. So ultimately, the unit of work done would be Newton meter. So this Newton meter is called as the joule. And the definition of this joule is given like this. 1 joule is defined as the amount of work done by 1 Newton. So here we are considering 1 joule. So we are defining the term of 1 joule here. So hence we are considering the amount of work done by 1 Newton when particle moves 1 meter. So the movement of the particle that is being achieved is 1 meter in the direction of force. Also, you need to consider that the movement is in the direction of the force. So this is the definition of the joule, wherein 1 joule is defined as the amount of work done by 1 Newton when particle is moving to 1 meter in the direction of the force. And coming to the multi-representation of this unit, kilojoules. We can represent the units in the form of kilojoules and millijoules. And how to give the representation of kilojoules is nothing but kilonewton into meter. As well, millijoules, it is represented as mj, and the units that we are going to take is Newton millimeter. So this is the variation of the units that is being selected for depending on the given inputs. So kilojoules is nothing but kilonewton meter and millijoules is nothing but Newton millimeter. Coming to next one, define power. So power is defined as rate of doing work. We all have already understood that the term rate represents the division of the quantity with time, right? Division of the quantity with time. So rate of change of velocity, rate of change of angular momentum, all these terms, all these definitions or all these representations in the term rate represents that the quantity's division by time. So here the definition of the power is given as rate of doing work. That means for a particular period of time, how much work is being done. It is treated as the power. So the representation will be given in the form of work done by time. Work done by time. So it will be treated in the words of or in the terms of work done per second. Then what is the unit of power? The unit of power is watt, which is represented using uppercase letter W and is defined as joule of work done in 1 second. As we have discussed, the joules representation, which is the unit of the work done in 1 second, is the watt. So the unit of power is given as power is equal to work done by time. Nothing but watt. W is equal to joule per second. Joules per second, which is the watts. So don't get confused with the representation. The W is the unit of power and work done representation we are going to give. Work done is generally taken as W, which is the joules. The unit of work done is given in joules and the unit of power is given as joules per second, which is watt. So depending on the given inputs, the given data, we are going to consider the units and the level of the representation. So the unit of power is work done by time. Then what is the conversion unit of horsepower to watt? So the metric horsepower, the horsepower or the metric horsepower is given as 735.75 watts. So 1 HP, generally you are going to see this in the form of the electrical dimension specifications, wherein 1 HP is treated as the 735.75 watt. Also, the representation of work energy equation. The representation of work energy equation, wherein the work energy equation is given as work done is equal to change in kinetic energy. So this is been detailedly discussed in our syllabus and we have done a couple of problems on this work energy equation. The definition says work done is equal to change in kinetic energy. This is the work energy equation, and we all know the work done is nothing but force into displacement, and kinetic energy is half mv square, and the change in kinetic energy we are going to take initial to final. So ultimate representation of this work done is equal to change in kinetic energy. The force we are going to take it as the resultant of the forces that are being acting in the system and distance to which the object is moving. It is given as change, nothing but the initial velocity and the final velocity's difference. The difference between initial velocity and the final velocity, kinetic energy. So here half mv square minus half mu square. So this is the work energy equation that we are going to consider, and we have solved many problems on this work energy equation. So from this work energy equation, we can understand that whatever work that is being done in the system by the forces that are being involved is equal to the change in kinetic energy. Then the representation of work done by a spring. So the work done by a spring is given as U is equal to minus 1 by 2 kx square. So here again in this equation, this minus term is being involved because the work that is being done is against the movement of the object. That means the force which is being applied in the system is in opposite direction to the movement of the spring. To understand this, you can take an example. Let us say this is the spring which is being attached here, fixed to one end, and the other end is free. Now, when we are applying the force on the free end in this direction, right? Or we can say when we are applying the force in this direction. So the movement of the object is happening and the spring is being compressed. That means it is gaining the tension. It is gaining the tension. So whatever direction the force is being applied, the work is being done in the opposite direction. Hence, we can say the work is being done by the spring in the opposite direction. So we are taking the negative form. That means the undeformed position of the spring, from the undeformed position of the spring, we are making the spring into a deformed position or deformed form, whether it may be a compression or elongation. After this deformation, if we are allowing the spring or the work is being done by a deformed spring to the normal form, then we can take the work done as 1 by 2 kx square. This equation is being taken when a deformed spring is happening to make some work. So work is done on already deformed spring and the spring is trying to come to the normal position. Then the direction in which the work is happening as well as the force that is being applied, both are in the same direction. So we can take it a positive sign. So this is about the definitions and terminologies in the particle dynamics and the work energy equation. This completes the session. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.